From bridges that defy gravity to cities carved out of mountains, China isn't just building infrastructure, it's rewriting the laws of possibility. But before we explore the jaw-dropping truth behind the most mind-bending megaprojects rising across China right now, hit that subscribe button, because what you're about to see might just reshape the planet itself. Nestled in the heart of Hebei province, just a brisk 100 kilometers southwest of the bustling metropolis of Beijing, a quiet revolution is taking shape, one that promises to redefine urban living on a global scale. The Zhong'an New Area, officially launched in 2017, is not just another city rising from the earth. It is a colossal vision crystallized into reality in under a decade, backed by a staggering $95 billion investment. Spanning over 2,000 square kilometers, an area larger than some small countries, Zhong'an was born out of China's strategic intent to ease Beijing's overpopulation and environmental stress while spearheading a model of sustainable urbanization. But what truly sets Zhong'an apart is its identity as a smart city on steroids, a living, breathing digital organism designed with intelligence at its core. Beneath the city's surface lies an equally ambitious undertaking, a sprawling subterranean network that integrates utilities such as power grids, water pipelines, and waste management with logistic tunnels that facilitate automated delivery vehicles and high-speed transit lines. This underground layer acts as a city within a city, reducing surface congestion and enhancing efficiency. On the surface, the city is punctuated by vast green belts and urban forests designed to combat urban heat island effects and support biodiversity. Architecture here is not just about aesthetics, it's functional ecology. Zhong'an is also a laboratory for emerging technologies. 5G connectivity blankets the city, enabling IoT devices, autonomous vehicles, and immersive digital experiences. With plans for vertical farming and AI-driven public services, this is a blueprint for how cities of the future might operate, not as chaotic hubs, but as harmonized ecosystems where technology and nature coalesce. If Zhong'an New Area is the brain, then the Zhong'an Railway Station is its beating heart, pumping lifeblood in and out with incredible speed and precision. Completed in just 2 years, a feat in itself for a structure of its magnitude, this station stands as a gleaming symbol of China's ambition and engineering mastery. Weighing in at a colossal 60,000 tons of steel, the station's architecture defies traditional design with sweeping curves and translucent solar roofs that not only bathe the interior in natural light, but also generate clean energy for the facility's operation. The station's design employs biomimicry principles, inspired by natural forms that balance strength and grace, creating a space that is as functional as it is breathtaking. Inside, crowds flow effortlessly through wide concourses equipped with smart navigation signage, augmented reality wayfinding, and AI-powered crowd management systems that monitor density and dynamically adjust passenger routing to prevent bottlenecks. Climate control systems adapt in real time to occupancy and weather conditions, maximizing comfort and reducing energy consumption. Perhaps most revolutionary is how the station integrates with the broader transport network. It acts as a multimodal hub, connecting high-speed rail lines, urban transit, and autonomous vehicle pickup zones. Platforms are equipped with sensors that track train arrival times with millisecond precision, feeding data to passengers via apps and digital displays. Zhong'an Railway Station isn't just about moving people. It embodies the future of travel, where infrastructure is smart, sustainable, and responsive. A gateway welcoming millions into China's next-generation urban landscape. Water scarcity has been a defining challenge for northern China for decades, threatening agriculture, industry, and urban growth. China's audacious answer is the South-to-North Water Diversion Project, arguably the largest hydrological engineering effort in human history, with a price tag topping $120 billion and a length exceeding 2,000 kilometers, roughly the distance from New York City to Denver. At its core, the project channels over 10 billion cubic meters of water annually from the water-rich Yangtze River Basin in southern China to the parched northern plains, including megacities like Beijing and Tianjin. But this is no mere canal, it's a marvel of engineering precision and scale. The central route, the project's backbone, incorporates an elaborate network of pumping stations, reservoirs, and tunnels, including a jaw-dropping feat of tunneling beneath the Yellow River. To overcome varied topography, engineers constructed 13-step cascade pump stations that lift water over mountain ranges in staged elevation increments, pushing the limits of hydraulic engineering. Technologically, the project employs advanced water quality monitoring and automated flow regulation systems to maintain ecosystem balance along the route. Aqueducts stretching up to 9 kilometers channel water with minimal loss, and sediment management systems prevent clogging, ensuring consistent delivery. Today, the south to north water diversion sustains the water needs of 170 million people, transforming China's northern economy and agriculture. More than infrastructure, it's a hydrological revolution rewriting the ancient rhythms of the country's rivers to sustain its future growth. The Himalayan challenge is to build a railway that dares to thread the needle through the world's most formidable mountain range, conquering glaciers, seismic zones, and oxygen-starved altitudes. The Sichuan-Tibet Railway, spanning nearly 2,000 kilometers, is China's boldest railway project to date, a feat that tests engineering, human endurance, and geopolitical resolve. From the subtropical lowlands of Sichuan to the high Tibetan plateau where oxygen levels dip to 40% of sea level, the railway encounters extremes few railroads face. Massive glaciers shift unpredictably. Avalanche zones require specialized protective galleries, and 14 active fault lines slice across the route, demanding earthquake-resistant design features. Tunneling through these mountains requires state-of-the-art technology. Some tunnels stretch for over 30 kilometers, and constructing them can take over 5 years apiece. Specialized tunnel boring machines equipped with adaptive sensors work under extreme pressure and temperature variations, while engineers monitor geological data continuously to mitigate collapse risks. Construction teams face challenges beyond geology. At 4,000 meters and higher, the rarefied air impairs worker endurance, necessitating oxygen supplementation and carefully monitored shifts. Machinery performance suffers as well, with diesel engines requiring modifications to operate efficiently at high altitude. Once completed, this railway will slash the journey from Chengdu to Lhasa from 36 hours to under 13, a transformation that will integrate Tibet more closely with the rest of China, economically, culturally, and strategically. In Gansu province, China faced a challenge that many would call insurmountable: how to build a sprawling new city when the land itself refused to cooperate. The region's rugged terrain, dominated by hundreds of steep hills and mountains, left almost no flat ground suitable for traditional urban development. Yet rather than bending to nature's limits, China embarked on an audacious plan to literally reshape the landscape. The Lanzhou New Area project demanded an unprecedented feat of geoengineering. Over 700 hills, some rising hundreds of meters tall, were systematically reduced. Massive earth-moving machines clawed into the rugged topography, moving over 700 million cubic meters of soil and rock. To put that into perspective, that volume could fill nearly 280,000 Olympic-sized swimming pools. This was not merely leveling land, but transforming a mountainous wilderness into a vast continuous urban expanse. This colossal operation required coordination on a scale rarely seen. Bulldozers, excavators, and conveyor systems worked round the clock, transporting earth to nearby valleys and riverbeds, carefully managing erosion risks and environmental impacts. Engineers implemented complex drainage systems to prevent flooding in the newly flattened zones, while reforestation projects reclaimed displaced ecosystems. The final product is staggering: an 86 square kilometer urban area larger than Manhattan. But size is just the beginning. Lanzhou New Area is a fully functional metropolis with an integrated infrastructure backbone. It boasts a network of subways weaving through its neighborhoods, state-of-the-art highways connecting industrial parks, and comprehensive social facilities including schools, hospitals, and cultural centers. Industry here isn't an afterthought. Advancing manufacturing hubs and tech clusters have been planted alongside residential zones, creating a city designed for both living and working. Piercing the skyline of Shanghai like a silver spear, the Shanghai Tower commands attention, not just for its record-breaking height, but for the ingenuity packed into every meter. At 632 meters tall, it claims its place as the second tallest building on the planet, towering over the bustling financial district with a confidence that is both architectural and symbolic. But what makes the Shanghai Tower more than just a monument to vertical ambition is its meticulous design to coexist sustainably with nature's forces. The tower's signature spiral twist isn't aesthetic whimsy. It's a carefully calculated response to the intense winds that whip through Shanghai's skyline. By rotating 120 degrees as it ascends, the structure cuts wind loads by 24%, dramatically reducing stress and sway, making it safer and more comfortable for occupants even in typhoon conditions. Its facade tells another story of innovation. The double-skin curtain wall envelops the tower like a protective shell, an air buffer zone that insulates the building year-round. This design reduces energy consumption by over 21%, slashing heating and cooling costs while keeping carbon emissions in check. Sustainability here isn't a footnote, it's a core principle. Inside the Shanghai Tower is less a building and more a vertical city. Spanning 128 floors, it hosts an array of functions stacked like layers of a living organism. Luxury hotels offering panoramic views, sky gardens breathing life into the heights, open office spaces fostering creativity, and observation decks where visitors can witness the sprawling urban tapestry below. Elevators in the tower are feats of engineering themselves, the world's fastest, reaching speeds up to 74 kilometers per hour. In less than a minute, they can whisk passengers from the ground floor to the top, a swift ascent through the clouds. Spread across an astonishing 700,000 square meters, Beijing Daxing International Airport is nothing short of an architectural marvel and a logistical masterpiece. Designed by the legendary architect Zaha Hadid before her passing, the airport's starfish-like layout breaks free from conventional terminal design, optimizing every inch for passenger convenience and operational efficiency. Costing $63 billion to build, Daxing is engineered to become one of the busiest airports in the world, designed to handle over 100 million passengers each year, a number that rivals entire national populations. This is a hub built not just for today's aviation demands, but for the skyward trajectory of global air travel in the decades to come. 4 runways anchor the sprawling complex, with provisions to add 2 more as growth demands. What sets Daxing apart is the remarkable passenger flow design. No traveler walks more than 8 minutes to reach their gate. This is achieved through a radial design that funnels passengers efficiently, eliminating long transit times and the congestion typical of large airports. Beneath the soaring roofline lies a technological ecosystem. An intelligent baggage handling system employs AI and automation to track, sort, and deliver luggage with unprecedented speed and accuracy. From check-in to boarding, data-driven systems monitor operations in real time, anticipating delays and reallocating resources instantly. Connectivity is another cornerstone. Daxing seamlessly integrates high-speed rail, metro lines, and bus terminals, allowing passengers to move effortlessly between air and land transport. The airport functions as a multimodal transport hub that knits together northern China's vast urban and economic zones. More than a gateway, Beijing Daxing is a statement of China's commitment to innovation, scale, and efficiency. A futuristic starfish stretching its arms wide across the sky, it redefines what an airport can be: fluid, fast, and profoundly human-centered. Spanning an astonishing 55 kilometers, the Hong Kong-Zhuhai-Macau Bridge is far more than just the longest sea-crossing bridge on the planet. It's a marvel of hybrid engineering and ambitious vision. This monumental structure combines 3 critical elements: a series of bridges, an undersea tunnel, and 2 massive artificial islands that anchor the tunnel's entrances below the surface. Together, these components create a seamless transportation artery linking 3 major urban centers: Hong Kong, Zhuhai, and Macau. Construction began in 2009 and took nearly a decade to complete, demanding an extraordinary commitment of resources, over $20 billion, and the labor of tens of thousands of engineers, workers, and planners. The project wasn't just a race against time, it was a battle against nature. Over 500 typhoons and fierce marine storms tested the resilience of the structure throughout its development, forcing designers to innovate in corrosion-resistant materials, flexible expansion joints, and aerodynamic profiles that could withstand relentless ocean winds and waves. The centerpiece, the 6.7-kilometer undersea tunnel, stands as one of the longest immersed tunnels in the world. Built from over 33 prefabricated tunnel segments, each weighing tens of thousands of tons, the tunnel was lowered and joined underwater with surgical precision. The design wasn't just about aesthetics or novelty. It was essential to preserve the busy shipping lanes and reduce environmental impact in the Pearl River Delta, one of the world's busiest waterways. Before the bridge, traveling between Hong Kong and Macau or Zhuhai involved long, congested ferry rides or navigating traffic-choked land routes. The new connection shrinks that journey from 3 hours down to just 30 minutes, an economic and social game-changer. By linking 86 million people into a single integrated economic zone, this bridge acts like a circulatory system, pumping commerce, tourism, and cultural exchange throughout the Greater Bay Area. It's a physical manifestation of regional integration, symbolizing China's growing ambition to unify its urban powerhouses into a world-leading mega-region. Stretching a staggering 2,298 kilometers from Beijing in the north to Guangzhou on the southern coast, the Beijing-Guangzhou high-speed rail isn't just the longest high-speed railway on Earth, it's the backbone of China's high-speed network, a spine that connects the country's political heart with its bustling southern economic powerhouse. Capable of trains racing up to 350 kilometers per hour, this line transforms what was once a grueling 22-hour trip into a swift 8-hour journey. That alone redefines the very concept of distance and time in China. This isn't just about moving passengers faster, it's about accelerating economic growth, shrinking regional disparities, and knitting together a vast nation that stretches thousands of kilometers. The scale of this project is mind-boggling. It required over 60 million tons of steel, enough to build more than 8 Eiffel Towers, and a financial investment of $234 billion. The engineering challenges were enormous, constructing tunnels through rugged mountains, building bridges over vast rivers and plains, and laying thousands of kilometers of precision track that can maintain ultra-high speeds safely and reliably. The route connects over 80 cities, from megacities with tens of millions of residents to smaller, formerly isolated urban centers now primed for new growth. Each stop on the line is more than a station, it's a catalyst for economic hubs, technology parks, and tourist destinations. The ripple effect is evident. Industry booms around the stations, real estate markets soar, and regional development accelerates. But perhaps the most profound impact is on people's lives. Time is the most precious resource, and by turning a day-long journey into a morning commute, the Beijing-Guangzhou HSR expands opportunities, whether it's for work, education, or leisure. It creates a new dynamic where cities are not isolated dots on a map, but parts of a connected ecosystem, fostering collaboration and competition alike. How does China build colossal infrastructure projects like the Hong Kong-Zhuhai-Macau Bridge or the Beijing-Guangzhou high-speed rail in a fraction of the time it takes elsewhere? The answer lies not in magic or mere financial power, but in a uniquely orchestrated system of governance, industrial coordination, and execution discipline that few countries have replicated. First, China's centralized governance model allows for streamlined decision-making and rapid policy implementation. While democratic systems wrestle with layers of approval, negotiations, and competing interests, China's system prioritizes national goals and mobilizes resources swiftly, often cutting through bureaucratic red tape. Second, vertically integrated supply chains spanning steel production, concrete manufacturing, equipment fabrication, and construction labor allow China to internalize almost every aspect of the process. Instead of waiting for disparate companies or contractors to align schedules, China's infrastructure machine is a well-oiled assembly line. Factories churn out materials precisely when and where they are needed, and massive logistics networks deliver them without delay. Finally, the workforce itself is a critical factor. China employs millions of skilled engineers, technicians, and laborers who operate within a culture of discipline, pride, and urgency. Large-scale training programs continuously upgrade skills, while government incentives reward efficiency and quality. Every tunnel carved, every bridge erected, and every rail laid sends a clear message to the world. China is not passively waiting the future, it is decisively building it, with a pace and scale that reshapes not only its own landscape, but the global order. China's infrastructure revolution is a harbinger of a new era. Which of these projects impressed you the most? Share your thoughts in the comments. Thank you for watching this video with us, and catch you in the next jaw-dropping mega projects shaping our world.